processing. There's a lot more we can do with image. Okay, so we are going to do pencil sketch now using Python, and for that we need CV2, which is already there. We have CV2, so we don't have to import that. So sorry, we don't have to install it. So we just have to import it. Import CV2, and one we already did was there. I copied it, so I can simply paste it. That was to display the image. So from google.colab patches image, import CV2. Now first of all, let me explain to you what image is, because people get a little confused here. Image is actually nothing but a matrix of numbers between 0 and 255. Okay. And when we say it is an RGB image, like we have a black and white image, we have a grayscale image, we have an RGB image, a grayscale image may also be an RGB image. RGB is red, green, and blue. Okay. So basically, RGB is a three-dimensional image, 3D image, you can say, although it doesn't look like a 3D, but there are three channels to it. You can say three channels, not 3D, three-dimensional. We can say three channels. That means you have three matrices of the same size, let's say 256 by 256, okay, of a red channel, green channel, and blue channel, R, G, and B. Same way we have HSV colors also. So we come to that as CMYK also format. There are different formats available, but RGB is the most common. So let's stick to RGB. So three layers, you can say, three channels, you can say, R, G, and B. They're all three matrices. Okay, so numbers only. So it is basically digitized. So image, once it is on a system, is just digitized. You are reading it as a matrix of numbers only, maybe of different size, may not be of the same dimension. 256 by 256 would be a square image. It could be a 32 by 32, 16 by 16, or it could be higher if it is a higher definition image, 1024, or maybe more. So it all depends on the type of image you are using. The dimensions may vary, but it is the principle, basic principle still remains the same. So normally we can rescale the image if it is too large and then perform the things we want to, but we are not going into image processing. We are going to do something very interesting. What we are going to do is we'll have an image and then get a pencil sketch for it. Okay, so we have the tools already available, which are there. Applications are always there, but programmers don't like applications of others. They like to see what happens and how it happens. Okay, so they have to do it, and that is what I'm going to show how it works. The application also has a code behind it, right? So let's see how it works. So we need two modules here. One is to show the image and one is CV2, which is going to handle my image processing part. Okay, so not a very uh, rocket science thing of a thing, like it is not a very big deal that you're converting into a pencil sketch. You will see that it's just a small thing you're doing. So no rocket science involved. It is not necessary you understand image processing or not, because you understand matrix. That is what you are studying from your childhood. I think in 10th you are introduced to matrices, so you know what is a matrix, and you can work on it. So that is not a rocket science. That is what I was saying. So first of all, I need an image. So let me have an image, and I think I use it somewhere. Give me 2 minutes, and I'll get the image, and I can use my own image also. Let me see if I can get it, and I can put it the right place. And um, after we do it, you guys will have to do and share with me. So anyway, so let me get the image. Okay, You just have to upload, so it should not be a big deal. I have a huge library for image processing. I normally save the uh, images so that I can have a face recognition thing ready if I want to. So all my friends and all, I've just copied their DPs. I tell them also that I'm copying your DP. So let me see. Okay, okay. I have so many folders, face recognition, pics, and here you are. Here I am. Okay, here I am. So I'm going to have me myself. Okay, so we have the image, and now oh, I'll just put here anuj.jp. JPEG. So I'm just putting the image, and what I need here is we have to convert the image to a grayscale image. So it is a BGR convert image. So we have to convert it into a grayscale image, RGB image basically it is. So we use BGR to gray here to convert it. Okay, so I'll just have a gray scale image is equal to CV2 dot CVT CVT color. Yeah, here I'll create another video also for this image and CV2 dot color color CV2. It should come actually. It's not coming because I put it in quotes. That's what it should come. CV2 dot is actually looking for a car classifier which is not there. I don't need that color. CV color already have taken. BG BGR. This red, green, blue, or blue, green, red is okay. PGR to gray. This is the command I'm going to use to convert it to grayscale image. CV2 dot CVT color image CV2 dot color BGR to gray. Looks okay to me. Let me run it and check. First of all, no, there is something wrong which I did. CVT color. There is something wrong here. CV2 dot CVT color looks okay to me. Okay, so this happens, and I'll show you the reason why it happened. Okay, see, now this error occurs when there is something wrong with the name of the file. You can see that this is giving you an error that there's something wrong with CVT color, but as that is not actually that. It is not that. There's nothing wrong in this line. The problem is on the line above it here. Oh, sorry. Okay. So just keep in mind this error. This error occurs normally. It's a normal thing, and it happens only when the color name of your image is not correct or the path is not correct. You have to see the path and the name. Now you have to invert the image. Invert the image. Okay. And converting, I told you we have colors from 0 to 255. So very simple. Inverted image would be, let's go. Inverted image is equal to 255 minus grayscale. Okay. Very simple. I use numbers normally. So grayscale, it is grayscale. Yeah. Is it right? It's like that. It's correct. Oh, um, now we have inverted. We have to blur it now. Okay. So blurred will be equal to. We can use CV2 here. We use Gaussian blur here. Not those who are knowing processing would know that they're different kind of blurs. Anyway, doesn't matter. We are using Gaussian. Gaussian function is there. That is what we are going to use. Now, we can have some size 21 by 21. And vary it and see. It should not be big. We have just converted into a block. We have blurred the image. The areas you can say pixels 21 by 21. Then inverted blur. Now you have to invert it again. Okay. Inverted blur. Blur the image will invert, and that will be again 255 minus blurred image. This is what we did. Okay. So first we have converted to gray, then inverted the gray, then blurred it, then inverted it back. Okay. Now I need the pencil sketch. So pencil sketch is equal to CV2 dot divide. Right. Now we have the grayscale. Then we have the inverted. Basically, you're dividing the images to a scale of with a scale of 256. 0 is double value. Now we are done with it now. Now pencil sketch CV2 dot divide grayscale image and the blur image. We are doing that inverted blur, the inverted blur and the grayscale. We're doing that, subtracting one image from the other, you can say, or dividing one image with the other one. And now we can use the CV2 dot show, and we have the image which we read. This is the original image. This is the original image we read. Then the pencil sketch is here. CV2 underscore I am sure pencil sketch. Just copy it. Okay. Very simple code. If you understand image processing, then it is really very simple. But even if you don't, this is again very simple. 8, 0. Okay. So all done, I think. Let me run it. I'll just close it so that we have a bigger view. So we have inverted the image, blurred the image, then again inverted the blurred image, then we are dividing the grayscale image with the inverted blur image, and that should be enough. And then we are just playing with the scale of 256. And this is the original image, my image, and this is the sketch, pencil sketch. There you are. As simple as that. Very simple. Now, I'll just show you something. What happens if I change this scale? I'll just copy this much as it is. You can copy this image and use it, paste it wherever you want. Okay. So let me put it here. And if I change it to 200, suppose, we have 255 colors, but if I change it to 255, you can see that it is there, but it is more like a gray image. The scaling factor matters. Okay, so it will be there definitely, but not as good as this one, which looks more like a pencil sketch. So few on just few steps, just a few lines of code, and you get the pencil sketch of your image. Now, what is the advantage of this? You can use actually this when you're using with your machines. You can get a pencil sketch of the machines and grayscale image, and then you can always segment it and see what is happening. You can use it with machines. You can use it with any image, and you can get the finer details from that. You can vary it and see. So you can even use it for segmentation. So any medical image, any machines or any image you pass it to it, it will just convert it into a pencil sketch, and this can you can get some finer details and you can get to work on it. You can use it, and this image can be used, and you can extract some features. You can use your deep learning algorithms and work on it. Okay, you can even use your disease data sets of a leaf, and you can put this code there, and just have to mm, get the thing. Okay, so let me have a file. Okay, we have some files here. So I have I'll just show you. Okay, uh, I have some data sets I'm just getting from there. And, have these spots. Let's copy it from here. Use, I'm just telling you, I'll just copy this. This is, I'll have to rename that. This is a huge file. And just, this is a brown rice. APG, just keep in mind, I'll show you there what happens if I just put it like this. I'm just putting rise.jpg, jpeg, okay, and we'll see that the error will be there. The error shown is here, which is again the same thing that it is not there. There's something assertion error is there, but the assertion error is actually because there is something wrong with the file. So I'll just run it again. Okay, so I did. Okay, again the file name is not correct because I did not use an underscore one. Now this seems to be correct. Now we can close it, and see, and you can get this thing out. Only the main brown part is there, which is highlighted, rest gone. So it is more clear. You can actually extract it, and you can get the features extracted, and then you can work on it easily. You can do that. So a lot more you can do with image processing in Python, but we are not doing that. We are more concerned about few interesting things. So we are just creating some pencil sketch. I was just showing you the application where it can be used. Pencil sketch, you can see that, and you can easily get the reason of interest. Uh, we call it ROI, and extract the particular part. Okay, so uh, this is what we are going to have here. So you can try